discuss ROC and AUC. We'll also discuss some more details about what are the classification metrics that can be used, and we'll learn how they are derived using the code and all of that. Okay, so we'll start with the story. The story is about radar and how radar was used in the early days, and then how a classification metric was created using the radar technology. Okay. So during World War II, the radar technology played a really crucial role in detecting some of the incoming enemy aircraft. So I hope you all know about the radar technology. You may have seen that in movies or everywhere, right? So you see a screen in front of you, which is green usually. You have a circle, and in that circle, there is a radius which is moving, like a clock. And then whenever it detects something, it highlights it, saying that this is the object they have detected, and whatever the speed of that object is, it tells you if you are at the center of it, how long it is going to take you to reach that particular point. Okay. Now, this radar technology is going to do basically a classification. It's going to either detect, so in the sky, it could be an aircraft which is of enemy, it could be your own aircraft, it could also be maybe a something else. Okay, in early days you didn't really have a lot of technology to identify correctly or identify more accurately, right? So there will always going to be some of the misclassifications. Correct. Sagar, turn on your camera. So there are always going to be some misclassifications. So we have seen the confusion matrix, and in confusion matrix, anything which is a false positive or a false negative is a wrong entry. Correct, is a misclassification. And they were usually humans who would see the signals and then decide whether that particular signal that was received on the radar, is it really a enemy's aircraft or it is someone's internal. So so we'll also have some of the internal ones, and then there are some enemy ones. So they called it something called as receiver operating characteristic. It was used in the context of radar technology, but all it tries to do is it tries to see what is the trade-off between the sensitivity and false positive rate. Okay, we learn what these two things are. So when we say trade-off, the way we discussed anything that says trade-off, it's always going to be competing against each other. So we have seen trade-off of what? Bias versus. So trade-off, bias versus. Bias versus क्या होता है अनिरुद्ध? आयुष? वेरिएंस, राइट? जब बायस,
Variance.
करेक्ट, जब बायस बढ़ता है
Hmm.
तो वेरिएंस कम होता है. Okay. So we have seen that trade-off. Similar trade-off can be seen in the sensitivity, which is the true positive
Yes.
rate, and the false positive rate. Okay. And that trade-off can be shown by using something called as an ROC curve, receiver operating characteristic curve. Okay. Uh, Now, since this is an old term, I think this basically means the one who is receiving the signal, how is he identifying some of the correct so how is he going to identify some of the correct enemy aircrafts, and how is he going to misclassify some of them? So obviously there are going to be some mistakes. And as you can imagine, if this was a real system that was used in World War II, and the person who is watching this particular signal, and if he misclassifies something as not an enemy ship, you can imagine how much how costly that one particular misclassification is going to be. Correct. So that could potentially mean that it's going to hit on your targets, and then it could also destroy many of your bases and all of that. Okay. And on contrast, Okay, on contrast of that, if it tells that it sees a friendly ship or it sees a friendly aircraft and says that's the enemy aircraft, so even that is an expensive one. Now you're going to shoot down something which is yours, correct? So that is what we are talking about here. So we are talking about trade-off between the true positive rate and the false positive rate. True positive rate means something which is actually positive, the ability of the classification or the ability of an algorithm to identify it to be a positive. So that is the true positive rate, which is the recall or the sensitivity. False positive rate basically means how many times of all the, oh god, people are still joining. Guys, you have to be on time, okay? You have to be before time. This is disturbing. Rohini, Ayush, turn on the cameras. Okay, so ROC curve basically represents two things, which is the trade-off between the true positive rate and the false positive rate. So false positive rate basically means of all the negatives which are actually negative, how many did the classifier miss? Okay, how many did the classifier say that it is not a negative but said it's a positive? Basically saying, if we take the example of our enemy ship here, and let's say enemy ship is the positive example. Okay, so if it's an enemy ship, then we say that it's a positive. If it's not an enemy ship, then we say it's a negative. That means of all the ships that were actually enemy ships, how many did the classifier or how many did the receiver, the person who's observing this, has identified them to be an enemy ship? That is what, that is a true positive rate. It is actually an enemy ship, and the algorithm or the person who is watching has also identified it to be a enemy ship. Whereas it is not an enemy ship, but the person who is watching it has identified it to be an enemy ship. Okay, so that is the false positive rate. The task is to increase TPR as much as possible and also to increase FPR as much as possible, which is not really something most of the classification algorithms do. So instead of that, we can have something called as ROC. And in addition to ROC, you also have something called as AUC, which is area under curve. Okay. So keeping that story in the back of the mind, and we also know how the what is the background of ROC curve now. Imagine that you have this particular graph on the right side. Okay. And on the right side, on x-axis, you have false positive rates. So false positive rate is nothing but false positive divided by false positive plus true negative. हमारा जो confusion matrix होता है. So I'll just put the confusion matrix here so that you can remember that. Um, yeah, I'll just put the confusion matrix here. So yeah, आपका confusion matrix है, correct? Let's put it here on the top. Okay, ये आपका confusion matrix है, correct? We learned this in the last session.
क्या चीज हाँ काट हुआ
Okay, Sonia and Saleha, turn on the cameras. So this is the confusion matrix. All right. Now look at this graph and try to understand what is false positive rate. Okay. As you can see here, जो आपका y-axis है, that is the true positive rate. That is derived using the first column. Correct? There's something wrong here. Give me a second. I think the confusion matrix गलत है. This is what the confusion matrix is. True and predicted. No, not this one. जो हमने पढ़ा है वो है ये वाला. Okay, so I'll explain you in the code as well, but don't worry about that part. Okay, so let's put it here. So you can check your notes too. आपके notes में भी होगा ये, correct? So if this is your confusion matrix, true positive or या फिर से गलत है. Predicted true positive. This is false positive. This, I'm not sure why this is giving me wrong answer everywhere. So we want predictions which is false positive. Okay, this looks correct. True positive, true negative. नहीं ये भी नहीं. What we learned was, okay. Let me just go back to the previous slides and I'll get it from there. We have this right. Let's put it here. Make this a little smaller. ओके, सो व्हाट यू हैव हियर इज अ कंफ्यूजन मैट्रिक्स, और हमें पता है कंफ्यूजन मैट्रिक्स में यहाँ पे ट्रू पॉजिटिव है, यहाँ पे फॉल्स पॉजिटिव है, फॉल्स नेगेटिव एंड ट्रू नेगेटिव. ठीक है, तो आपका जो y एक्सिस है, दैट y एक्सिस इज डिराइव्ड फ्रॉम द फर्स्ट कॉलम. ट्रू पॉजिटिव डिवाइडेड बाय द ट्रू पॉजिटिव प्लस फॉल्स नेगेटिव, दैट इज एक्चुअल पॉजिटिव्स, दैट इज योर टीपीआर. ओके, और आपका जो x एक्सिस है यहाँ पे विच इज द फॉल्स पॉजिटिव रेट, दैट इज डिराइव्ड फ्रॉम द सेकंड कॉलम. सेम फॉर्मूला, टॉप में सिर्फ अभी आपका कॉलम चेंज हो रहा है. यहाँ पे ट्रू पॉजिटिव डिवाइडेड बाय एक्चुअल पॉजिटिव था, यहाँ पे फॉल्स पॉजिटिव डिवाइडेड बाय एक्चुअल नेगेटिव है. ठीक है, so it's pretty simple to remember this. You just have to remember this particular diagram. You should know that यहाँ पे predictions है और यहाँ पे actual है. Okay, so take down that and then we'll continue our discussion. Atharva, Monica, you have to be on time, before time in fact. You already are 15 minutes late. You have to be on time, Atharva. You are 15 minutes late for the session. Yeah.
Sorry.
Same goes for the Monica.
Yes, sir.
Yeah, turn on the cameras too. Okay. So to remember, this is very easy, right? So all you have is on y-axis, your first column, and on the x-axis, your second column. But make sure you remember this in only one format. Okay. So predictions are here and actuals are here. Sometimes what happens is अलग अलग टेक्स्ट बुक में अलग अलग डायग्राम्स दिए जाते हैं. So you'll have actuals here and then you'll have predicted here. Then you'll have positive years and then negative years, or then the positive here, negative here, and the positive here. Okay, it's all confusing because of that, but make sure you follow one particular format and stick to it. Okay, until and unless you are really used to understanding true positives, false positives. If you don't get used to that, then just stick to one particular format. Even if you get a result which is not in this format, try to get it into this format first, and after that try to make sense out of it. Even in the interviews, you'll be asked what is the false positive rate, what is the confusion matrix. So visualize this particular diagram in your mind and just draw it in on the paper so that you don't get confused ever. Okay, even in the interviews. So there's a trade-off between the true positive rate and the false positive rate. Okay? You cannot achieve both at the same time. Either you'll have good true positive rate or you'll have a good false positive rate. You'll have a bad false positive rate. Okay, because both of them are um, so lower the value of true positive, the better it is. Sorry, higher the value of true positive, the better it is, and lower the value of false positive, the better it is. Okay. अगर true positive का if the true positive rate is 100%, that means actually maybe पॉजिटिव है वो और आपने प्रेडिक्शन भी पॉजिटिव दिया है करेक्ट सो योर ट्रू पॉजिटिव इज 100% दैट मीन्स ट्रू अगर हमने ये एग्जांपल लिया तो उनको सच में हार्ट डिसीज है और आपने प्रेडिक्शन में भी बताया दैट ही हैज अ हार्ट डिसीज ठीक है सो दिस वैल्यू विल बिकम 1 इन दैट केस ओके this value we don't know yet for that we need these two other columns here so we'll take an example and then we'll try to understand what that is
Yes.
now let's focus on this particular diagram which is the ROC curve. The dotted line that you see here, you can assume that to be a coin flip. Okay. You flip a coin and then you randomly assign someone has a heart disease and someone does not have a disease. Ideally, your classifier should be better than the random coin flips. Correct? अगर आप classify कर रहे हो कुछ, that means you have more information. You are just not going to do a coin flip and decide who is going to get what. So this dotted line is nothing but the random classifier, which basically is doing a coin flips to really tell you if the person has a heart disease or not. And if the ROC curve is above this particular line, then you say that it is better than the random classifier. Agar it is not better than the random classifier, then that model is incorrect indirectly, right? Because you are doing negate, you're just not even doing as good as the random classifier. So think of this random classifier as the baseline, and then any model which is on the left side of this random classifier, left top side of the random classifier is the better model. Okay. So when we, I'll show you how to draw the ROC curve. Okay, don't worry about that. Imagine karo that you have three models. Model number one is the orange line. Model number two is the green line, and model number three is the blue line. Okay. So according to the logic, any model which is as far as possible from the random classifier on the left top, that is a better model. The closer the model or the closer the ROC curve for the model is to the random classifier, the worst it is. Okay. You will also see sometimes that there are random, some of the models are less than the random classifier. That basically is an error. It just tells you that there's some error in the code and you have to fix that. But usually most of the models will always be better than the random classifier. Now you have a perfect classifier here. Okay, perfect classifier means someone whose true positive rate is 1 and false positive rate is 0. मतलब उसने क्या किया है उस क्लासिफायर ने या फिर उस पर्टिकुलर मॉडल ने जितने भी एक्चुअल में पॉजिटिव है उनको उसने बता दिया दैट दीज आर पॉजिटिव प्रेडिक्शंस करेक्ट है ट्रू पॉजिटिव के और उसने एक भी फॉल्स पॉजिटिव की मिस्टेक नहीं की है करेक्ट दिस विल बिकम 0 this will become 1. Okay, so that is the perfect classifier. If you can get a perfect classifier, then you have to check the data again just to make sure that if you have any variable which cannot be observed before the output variable. Okay, so you'll usually see that examples. But if you see a perfect classifier, it basically means that there is some kind of a leakage in your model. Okay, मतलब imagine करो कि perfect classifier would be um, if you are checking this particular heart disease and if you're having a column which basically measures if there is a block in the artery or not. Okay, If you have that column, then obviously you have a heart disease, correct? And you cannot use that particular column in your data. If you use that, that means it's as good as knowing whether the person has the heart disease or not, correct? So there's a leakage in the model there itself. So that may be a bad example, but that's how the leakage works. So you have a variable which is an independent variable, but that independent variable cannot be observed before your dependent variable, or the dependent variable and the independent variable only can be observed simultaneously. In that case, you have a model leakage. Okay. So if we see one of those examples in the sessions, I'll let you know. Okay. All right. Now let's do one thing. Let's open the Kaggle notebook and try to understand all of these. So let's open this sklearn metrics and what this particular module has. Then so whenever you build a model using scikit-learn or sklearn, you're going to have to create some of the metrics or get some of the scores. If you're building a regression model, in that case, metrics are RMSE, mean absolute error, R squared value. So all of those are metric when you build a regression model. When you build a classification model, you have precision, specificity, then you have classification, then you have accuracy, F1 score. All of these are metrics used for the classification.
Yeah.
Okay,
For
and
classic.
all these metrics are present in the model evaluation or the metrics module, which is present in scikit-learn. So you'll see all these names here: accuracy, balanced accuracy, which is I think weighted accuracy, top key accuracy, precision, F1 score, F1 micro. So there are various version of this. You don't have to remember all of this, but if even if you remember the main ones, that is fine. So for example, AUC curve, okay, ROC AUC, F1 accuracy, then you have precision, recall. So these are the main ones. If you remember this, then that is enough. Okay. And if you open this link, it will show you all the things. So for classification, these are the metrics. For clustering, these are the metrics. For regression, these are all the metrics that are available. Okay. R square, then some of these are not useful at all, but will if there's something that is going to be useful, I'll explain you at that time. So you have this explained variance and R square are almost same. Only thing is explained variance is going to be in terms of the same scale as a dependent variable, whereas R square is more relative. It is always going to be between value of R square is always going to be between, what is the range of R square?
0 to 1.
Correct. Right. So R square is always going to be between 0 to 1, whereas explained variance depends on the range of your dependent variable itself.
Yeah.
Yeah. Okay. So from that scikit-learn metrics, we are going to import accuracy score, precision score, recall score, F1 score, ROC, and confusion matrix. We have learned all of this except this particular score, which is ROC AUC. Okay. So let's focus on this accuracy, precision, recall, and all of that, and then we'll come back to this ROC AUC in some time. Okay. Now imagine that we don't need this part here. Imagine that these are the actuals. Okay, and these are the predictions. एक मॉडल कोई तो आपने बिल्ड किया है और उस मॉडल ने ये आपको प्रेडिक्शंस दी है, तो ये 1 ये करेक्ट है, ये 0 0 ये करेक्ट है, ये 1 1 ये करेक्ट है, ये 1 1 ये करेक्ट है, ये भी करेक्ट है, ये भी करेक्ट है, ये भी करेक्ट है, यहाँ पर एक मिस्टेक है. ओके, सो द एक्चुअल वैल्यू इज 0 बट द प्रेडिक्शन इज 1. Then you have this correction, correct here, you have this here. Let's just do one more here, error here. Okay, ये 10 मैं ऐड कर देता हूँ. तो यहाँ पे एक्चुअल वैल्यू 1 है, लेकिन प्रेडिक्शन मेरा बोल रहा है 0 है. ओके, ऑल गुड टिल हियर.
Yes, sir. Yes, sir.
Now what are we going to do is we are going to get the accuracy score of this particular thing. We're going to get the precision score, recall score, F1 score, and the confusion matrix. Okay, in order to do that, we obviously have to first import all of that and then just call all of these functions. So if you open the accuracy score, that is a function in sklearn. Okay, it takes what is the true value, what is the prediction. Okay, now we go back to the code and see what is the true value and what is the prediction. That is what we send. Just do a 2f here. उसके बाद में क्या है, precision score. So precision score will also take something similar here. Search it here itself. Precision score क्या लेता है, true value and the predicted value. Again, let's go back to the code and check. Precision score, true value and the prediction value. कि array है ना, हमारा आउटपुट हमेशा array रहेगा. Predictions हमारा, we have to compare true versus predictions to get all of these scores. Okay, recall score के लिए क्या लगेगा हमें. First of all, let me just check here. Sometimes what happens is recall score के लिए भी same. So first you take the true positive. First you get the actual positive and then the predictions.
Predicted.
फॉर्मूला यहाँ पर लिखा हुआ है, आपको पहले से फॉर्मूला पता है रिकॉल स्कोर का, ट्रू पॉजिटिव डिवाइडेड बाय ट्रू पॉजिटिव प्लस फॉल्स नेगेटिव. ठीक है, so this is what the value it is going to give you. Now if you go back to the code, try to run all of this. Okay, it will give all the values that you need. We'll just check this confusion matrix first because this might be confusing for some of you. I'll just why is that. तो जब मैं इसका डॉक्यूमेंटेशन ओपन करता हूँ, it also takes true and predictions. ठीक है, so if I go here, it will take uh, water is my true, which is my y true, correct, and it will also take water is a predicted value. And अभी जब मैं डॉक्यूमेंटेशन चेक करता हूं तो इट टेल्स मी. ठीक है, तो C00 मतलब क्या है, मेरा ट्रू नेगेटिव है. ठीक है, नाउ लेट्स जस्ट सॉरी, I'll just put back here. I need this particular text here. Okay, I'll just explain you why do I need that. थोड़ा सा वो डॉक्यूमेंटेशन कंफ्यूजिंग है, so that you should know what it is. ठीक है, तो the way it returns a confusion matrix, it says true negative first. Okay, उसके बाद में it gives you false positive, false negative, then it gives you true uh, positive, and then it gives you false positive. Let me just check, this is what the documentation says. तो डॉक्यूमेंटेशन जब हम लोग पढ़ रहे हैं तो बोल रहा है C00 मैट्रिक्स का 00 इज ट्रू नेगेटिव, मैट्रिक्स का 10 इज फॉल्स नेगेटिव. सो 10 मतलब रो नंबर 1 column number 0 is false negative. So if
Column
you go
number
back
zero.
here, so this is false negative. Okay, उसके बाद में if you just go back to the here, C11 is a true positive. Okay, तो आपका ट्रू पॉजिटिव कहाँ पे आ रहा है, यहाँ पर आ रहा है ट्रू पॉजिटिव, और बचा क्या है फॉल्स पॉजिटिव विच गोज हियर. ओके, आपका जो कंफ्यूजन मैट्रिक्स वाला आउटपुट है, दिस इज व्हाट द आउटपुट लुक्स लाइक. लेकिन हमने क्या पढ़ा है अभी तक, हमने पढ़ा है ट्रू पॉजिटिव, फिर हमने पढ़ा है फॉल्स पॉजिटिव, फिर हमने पढ़ा है फॉल्स नेगेटिव, और फिर हमने पढ़ा है ट्रू नेगेटिव. ये हमने पढ़ा है, करेक्ट. दिस इज व्हाट वी हैव लर्नड. बट जो कंफ्यूजन मैट्रिक्स है उसका आउटपुट कुछ ऐसा आता है. तो इन ऑर्डर टू गेट इट बैक इन द वे वी हैव लर्नड, हम एक फंक्शन को यूज करते हैं. ठीक है, कंफ्यूजन मैट्रिक्स तो कॉल करते ही है, कंफ्यूजन मैट्रिक्स पे रेवल नॉट नाम का एक फंक्शन है वो कॉल करते हैं. इसके वजह से क्या होता है, जो आपका टू डिमेंशनल एरे है, जो आपका टू डिमेंशनल एरे वो कन्वर्ट हो जाता है इन अ टपल ऑफ दिस. सो आपका ट्रू नेगेटिव, फॉल्स पॉजिटिव, फॉल्स नेगेटिव और ट्रू पॉजिटिव, ये आपको अलग अलग वैल्यूज मिल जाती है। देन यू कैन बिल्ड द कंफ्यूजन मैट्रिक्स द वे यू वांट इट, जिसमें आप कंफर्टेबल हो वैसा कंफ्यूजन मैट्रिक्स आप बिल्ड कर सकते हो। ओके, लेट मी जस्ट पॉज हियर टू सी इफ एनीवन हैव एनी क्वेश्चंस। Okay, so sometimes what happens is different implementations will have their own way of representing things, correct? And because they represent it differently, uh, you'll have to be careful कि जो output जो आपको आ रहा है, you should know what that output is. So don't assume कि always आपको वही मिलेगा output जो आपने पढ़ा है, but this ravel function will give you correct values back, and then you can build whatever you want out of it. आपको confusion matrix build करने के लिए चार ही चीजें लगते हैं, correct? True positive, false positive, true negative, and the false negative. So we just get that functions values out of it, and then we can build our own confusion matrix based on whatever the values we get. Okay.
Yes.
Yeah. So let me just close this. So make sure when you call this confusion matrix, don't get confused that why is it giving you different values. Okay, it giving you different values because it's having something else. Now अभी हम लोग क्या करते हैं, सेंसिटिविटी निकालते हैं, स्पेसिफिसिटी निकालते हैं, फॉल्स पॉजिटिव रेट निकालते हैं। ठीक है, फॉल्स पॉजिटिव रेट इज नथिंग बट योर फॉल्स पॉजिटिव डिवाइडेड बाय फॉल्स पॉजिटिव प्लस ट्रू नेगेटिव। ठीक है, दैट
True
इज अ फॉल्स
negative.
पॉजिटिव रेट, दैट इज अ फॉल्स पॉजिटिव रेट। और ये आरओसी कर्व वगैरह सब कुछ आपको मिल जाएगा वैसे ही। ठीक है, व्हेन आई रन दिस आई विल गेट द वैल्यूज हियर नाउ। ठीक है, तो एक एरर आ गया यहाँ पे सेंसिटिविटी का, वैल्यू इज नॉट डिफाइंड हियर। तो एक्यूरेसी है 0.8, दो गलतियां होनी चाहिए यहाँ पर। आपके पास 10 डेटा पॉइंट से 10 में से दो गलतियां है। गलती नंबर 1 इज दिस, second mistake is here, that's why the accuracy is 80%. Okay, the accuracy is 80% here. Precision is 0.83. Why is that? We can check here, confusion matrix से पता चल जाएगा। confusion matrix हमारा ऐसा है, तो okay, if you can write this confusion matrix on your paper and then tell me what the precision, recall and all of that is. Okay, just एक बार ये लिख लो आपके नोटबुक पे पेन और पेपर से। ठीक है, tell me just precision, recall, sensitivity and specificity, what do you get? ये फर्स्ट रो है, ये सेकंड रो है आपकी। ठीक है, right? Saleha, you have to tell me the answer. Okay, calculate the precision and tell us how you calculate the precision, calculate the recall and tell us how you calculated the recall. Yes, Saleha, you got the answer. Nikita, if you want to join the session, you have to join on time. Okay.
Yes, sir.
Yeah. All right. Sagar, what is the answer? Recall कितना आ रहा है? Ignore this. Okay, this might be wrong. But what is your answer?
5/8.
Mm-hmm.
5/8.
5/8. कितना आता है 5/8? Is that the recall?
0.625.
सबको वही आ रहा है recall 5/8? ये confusion matrix सही वाला है, ठीक है? So this is the first row. This is the second row. What is the formula of recall?
True positive divided by true positive. True positive divided by true positive plus false negative.
Okay. So what is the recall you're getting?
सर 5/6 आएगा
5/6, correct? So ये
हाँ
सही है.
यस
यहाँ पे जो यहाँ पर प्रिंट है वो सही है. Precision कितना आ रहा है?
प्रिसीजन भी सेम ही आ रहा है
सेम ही आ रहा है, correct? Okay.
यस
What about false positive rate? False positive rate के बारे में क्या बताया था हमने?
ये 1/4 आएगा सर फॉल्स पॉजिटिव डिवाइडेड बाय फॉल्स पॉजिटिव
Actual
प्लस ट्रू
positive.
नेगेटिव
Sorry. False positive divided by actual negative. Correct?
यस
तो ये 1/4 आएगा. So makes sense. Okay. So I think that's fine. You can do it offline. It's just something that needs a little bit of practice because this confusion matrix itself, as the name suggests, is confusing. And I agree. Precision recall, all of this. The way I remember it, I just remember this one particular diagram, and I remember all of them using this. So if I want to do a recall, I know that I can do a recall by using the column, this column. Okay, true positive divided by this particular columns full. If I want to do precision, the column remains same. I have to do something horizontal here. That will give me the precision. True positive divided by true positive plus false positive. Okay, so true of precision is horizontal, recall is vertical. Okay, that's how I remember it. And then when you talk about the AUC or a ROC curve, that's also is easy. So this is y-axis and this is the x-axis. Okay, so I hope that helps, but you can come up with your own method of remembering things.
Yes, sir.
Okay, and sensitivity or recall दोनों एक ही है, तो उसके बाद में you don't have to remember all of them. Okay, you just have to remember a couple of them, and ये matrix important है सिर्फ. Don't get mixed up or don't get this wrong. ठीक है, ट्रू पॉजिटिव को ट्रू पॉजिटिव ही बोलना है, ऐसे नहीं कि गलती से आपने फॉल्स पॉजिटिव को फॉल्स नेगेटिव बोल दिया एंड देन इट्स ऑल मेस्ड अप आफ्टर दैट. ठीक है, इफ यू मेक मिस्टेक इन क्रिएटिंग दिस मैट्रिक्स, then everything else is going to be messed up. Okay, all right. uh, Now let's try to understand what is this value that we are getting here, ROC AUC. Okay, so the ROC AUC score is nothing but the area under the curve of your ROC diagram. Okay, आपका जो ROC diagram है, so this is your ROC curve, इसका एरिया अंडर द कर्व कितना है? अगर ये परफेक्ट क्लासिफायर होता तो एरिया अंडर द कर्व कितना होता? ये लाइन यहाँ से ऊपर ज्वाइन कर देता मैं और ये लाइन यहाँ से यहाँ ज्वाइन कर देता. एरिया अंडर द कर्व कितना होता उस केस में?
हो जाता है हाफ बेस इनटू हाइट
बेस
एरिया ऑफ
कितना है?
द
1.
ट्रायंगल. यस
ट्रायंगल का एरिया
बेस 1
एरिया अंडर द कर्व, एरिया अंडर द कर्व. ट्रायंगल का एरिया क्यों निकाल रहे हैं आप लोग? एरिया अंडर द कर्व, ये कर्व के अंडर कितना एरिया है टोटल?
स्क्वायर है
स्क्वायर है, करेक्ट?
सर
तो स्क्वायर
स्क्वायर
कितना हो
स्क्वायर
जाएगा?
स्क्वायर
1 into 1, करेक्ट?
1 into 1. यस सर.
तो AUC of a perfect classifier is 1. तो AUC का जो रेंज है that is always going to be between 0 and 1. Okay.
Okay.
If this is a perfect classifier, then the completely opposite of this classifier is someone who is going to have its point here. Our area under the curve of this particular line is going to be 0, right? So 0 multiplied by 1 is 0, correct? This is a random classifier, coin flip, but this is a opposite of all the perfect classifier, this particular point. Okay. Now area under the curve जितना 1 के पास होगा उतना अच्छा मॉडल रहेगा वो. Okay. The more closer to the 1 the value is, the better the model is. So यहाँ पे AUC आपका वैल्यू आ रहा है 7917. Okay. This is just telling you what is the area under the curve of the ROC. ठीक है. Now let's try to understand ये ROC build कैसे करते हैं. Okay. So it's kind of an interesting way of building. There's an interesting way of building it. Imagine करो आपके पास ये actual values है. Okay. आपके पास ये actual values है और आपका जो classifier है वो 0101 नहीं दे रहा है, उसके जगह पे वो आपको दे रहा है probability of it being 1. मतलब अगर इसने 0.3 बोल दिया so there is a 30% probability that this is 1. 0.5 बोल दिया तो there is a 50% chance that this is a 1. 0.5 बोल दिया that there is a 50% chance that this particular value is 1. Let me just line them up correctly so that you all will be able to follow properly.
Yes.
I hope this is better now. Okay. So ये true value 1 है. What is the probability of it being 1? 0.3. What is the probability of it being 1? ठीक है, 1 की probability है ये, 0 की probability नहीं है. अगर ये actual value 0 है, this is again probability of 1. Okay. This is again probability of 1. This is again probability of 1. This is probability of 1. This is probability of 1. Probability of 1. There is a 10% chance that this is a 1. There is a 40% chance that this is a 1. There is 75% chance that this is a 1. There is 40% chance that this is 1. Okay. अभी हमें क्या करना है, ये जो स्कोर है ये स्कोर यूज करके हम एक थ्रेशोल्ड सेट करते हैं. हम क्या बोलेंगे, जब भी स्कोर 50% से ज्यादा रहेगा तब उसको हम 1 बोल देंगे और 50% से कम रहेगा तो उसको हम 0 बोल देंगे. सो एक प्रेडिक्शंस नाम का एक ये निकालते हैं, एरे निकालते हैं. ठीक है. तो यहाँ पे प्रेडिक्शन क्या आएगा पहले वाले का, % से ज्यादा वाला मैं बोल रहा हूँ. ठीक है. 50% से ज्यादा रहेगा तो प्रेडिक्शन क्या आएगा यहाँ पे, यहीं पे डालता हूँ ऊपर. ठीक है. तो क्या रहेगा प्रेडिक्शन यहाँ पे,
0.
पहला 0. ठीक है. व्हाट अबाउट सेकंड प्रेडिक्शन,
1.
इससे ज्यादा रहेगा तो 1, 50 रहेगा तो 0. ठीक है.
0.
0.
यहाँ पर
0.
0.
यहाँ पर 0. यहाँ पर मैं यहाँ पे 0 डालना बोलता हूँ. What about this?
1.
1.
1.
0.
What this?
1.
0.
What this?
0.
This?
1.
What this? 0.
0.
करेक्ट. तो अभी ये आपका प्रेडिक्शन है. ओके. ये प्रेडिक्शंस यूज करके मैं कंफ्यूजन मैट्रिक्स निकाल सकता हूँ, ये प्रेडिक्शंस और ये ट्रू वैल्यू निकाल यूज करके.
Yes.
Yes.
दिस इज एट
Yes.
50%. ठीक है. नाउ लेट्स से मैं 50% नहीं, मैं बोलता हूँ 40% चाहिए मुझे. अब क्या होगा, इसकी वैल्यू कितनी आएगी, 0 आएगी तभी भी. करेक्ट.
0.
वैल्यू कितनी आएगी,
1.
ये 1
1. 1.
ये भी
1.
1
1.
ये 1 हो जाएगा. ये
0.
रहेगा 1
1. 0.
0 रहेगा,
ये
ये भी 0 ही रहेगा, 50 से बड़ा चाहिए, राइट?
1
ये भी 0। ओके, ये है मेरा सेकंड प्रेडिक्शन। ओके, अभी ये प्रेडिक्शन चेंज क्यों हुए? क्योंकि मैंने मेरा थ्रेशोल्ड चेंज किया। ठीक है, जो मेरा थ्रेशोल्ड पहले 50% था, उसको चेंज करके मैंने 40% कर दिया। जैसे ही मैंने मेरा थ्रेशोल्ड कम कर दिया, ओके, जैसे ही मेरा थ्रेशोल्ड कम हो गया, तो क्या बढ़ गया यहाँ पे? फॉल्स पॉजिटिव बढ़ गया या फिर फॉल्स नेगेटिव बढ़ गया? थ्रेशोल्ड कम किया तो फॉल्स पॉजिटिव बढ़ गया या फॉल्स नेगेटिव बढ़ गया? सोचो थोड़ी देर के लिए।
फॉल्स पॉजिटिव बढ़ गई।
तो मेरे फॉल्स पॉजिटिव बढ़ गए। ठीक है, सो जस्ट राइट इट डाउन।
यस
ठीक है, फॉल्स पॉजिटिव इंक्रीज्ड। इसका अपोजिट, जब हम लोग थ्रेशोल्ड कम करते हैं तब क्या होगा? फॉल्स नेगेटिव के बारे में बताओ तब। ठीक है, तो लेट्स से अभी थ्रेशोल्ड में 40 का मैं चेंज कर देता हूँ, डू इट, इसको मैं कर देता हूँ 60। ठीक है, तो 60% कर देता हूँ इसको। तो उस केस में क्या आएगा? ये 0 रहेगा, और 60 नहीं बोलता हूँ मैं, इसको 75 कर देता हूँ। ठीक है, लेट्स मेक 75। 75% थ्रेशोल्ड कर दिया, तो ये 0 हो गया, ये भी 0 हो गया, ये भी 0 हो गया, ये भी 0 हो गया, ये 0 ही है, ये 1 रहेगा, ये भी 0, ये 0, ये भी 0 हो गया, ये भी 0 है। करेक्ट। व्हाट अबाउट माय फॉल्स नेगेटिव? क्या हुआ यहाँ पर? फॉल्स नेगेटिव इंक्रीज हुआ है? इंक्रीज हुआ, रिड्यूस हुआ? फॉल्स नेगेटिव, व्हाट हैपेंड? एक काम, कंफ्यूजन मैट्रिक्स बनाओ इसका। ठीक है, कंफ्यूजन मैट्रिक्स बताओ इसका क्या है? कंफ्यूजन मैट्रिक्स क्या है? ऊपर नीचे रखता हूँ मैं, सो दैट यू कैन डू द कंपैरिजन इजीली। ठीक है, कंफ्यूजन मैट्रिक्स बताओ, फिर इसका कंफ्यूजन मैट्रिक्स बताओ, फिर मैट्रिक्स बताओ। पहले इसका बताओ कंफ्यूजन मैट्रिक्स। ओके, सही है कंफ्यूजन मैट्रिक्स। व्हाट अबाउट दिस? So prediction has to be true and the value has to be 0. So ये एक गलती है, एक ही गलती है यहाँ पर। और ये क्या है? Actual is true, but prediction is 0. Actual is true, prediction 0. 1.
1.
एक गलती है यहाँ पर, ठीक है? What about this? 4.
That is 4.
Okay. Now, as we can see here, जब हमने threshold कम किया, तो हमारा false positive बढ़ गया, ठीक है? पहले false positive rate कितना था? 0 था, करेक्ट?
Yes.
जैसे ही हमने थ्रेशोल्ड कम किया, हमारा फॉल्स पॉजिटिव रेट बढ़ गया। वन सेकेंड, फॉल्स पॉजिटिव है ना वो, या फॉल्स पॉजिटिव रेट बढ़ गया। ट्रू पॉजिटिव रेट, फॉल्स पॉजिटिव रेट। जैसे ही हमने थ्रेशोल्ड बढ़ाया, तो हमारा ट्रू पॉजिटिव रेट बढ़ना चाहिए। ट्रू पॉजिटिव रेट कितना है यहाँ पे?
1.
1। ये कितना है गलतियां? वन सेकेंड, सो देयर इज अ 1 2 3 4, दैट इज दिस थिंग। ओके, व्हाट अबाउट दिस?
0.
यहाँ पर 0 आया।
0. यहाँ पे 5. 5.
I think this may be wrong. False positive rate reduce होता है बस. Let's just focus on one thing. I think we just try to do it from both sides. False positive rate कम हो गया अपना. False positive rate 0/5 हो गया और यहाँ पे false positive rate 0.25 है, correct? False positive rate कैसे निकालते हैं? 1 divided by 5. यहाँ पर 0 divided by 5. यहाँ पर भी 0 divided by 5. Okay. Now at every point we are getting two different values. ठीक है, तो आपको क्या मिलेगा यहाँ पर? यहाँ पर आपको एक false positive rate मिलेगा, ठीक है, और आपको एक ट्रू पॉजिटिव रेट मिलेगा यहाँ पर। ये क्या है? एक टपल है, एक्स वाई वैल्यू की तरह ही है। ये भी एक एक्स वाई वैल्यू की तरह है। ट्रू पॉजिटिव रेट इसका मिलेगा, एक फॉल्स पॉजिटिव रेट इसका मिलेगा। इसी तरह से यहाँ पर भी आपको एक ट्रू पॉजिटिव रेट और एक फॉल्स पॉजिटिव रेट मिलेगा, ठीक है? यू गेट दिस एक्स वाई वैल्यूज, ओके? ये अलग अलग एक्स वाई वैल्यूज मिल रही है आपको, और ये अलग अलग एक्स वाई वैल्यूज मिलके आप एक प्लॉट बना सकते हो कुछ इस तरह से। आपको क्या करना है? सिर्फ थ्रेशोल्ड चेंज करना है। यहाँ पर थ्रेशोल्ड आपका 1.9 था, यहाँ पर थ्रेशोल्ड 0.9 है, यहाँ पे थ्रेशोल्ड 0.75 है, 0.5 थ्रेशोल्ड है, 0.4 थ्रेशोल्ड है, 0.3 थ्रेशोल्ड है और 0.1 थ्रेशोल्ड है। Okay, so every time you change the threshold, you will get a different confusion matrix. At every different confusion matrix, you will have different true positive rate and a different false positive rate. Does this make sense?
Yes.
Yes, sir.
Okay, that is all this ROC curve is. Okay, ROC curve build करने के लिए आपको लगते हैं predictions के साथ साथ percentages, what is the probability, और वो थ्रेशोल्ड आपको सिर्फ ऊपर नीचे करना है। जैसे आप थ्रेशोल्ड चेंज करते हो वैसे ये कर्व बिल्ड होते जाता है, ठीक है? यू कैन हैव इट मोर स्मूथ। आप ये 0.1 के जगह पे 0.1 के बाद में 0.3 पे जंप किया ना आपने, तो 0.3 के जगह 0.3 पे जंप नहीं करना है आपको। लेट्स अज्यूम दैट यू जंप इट एट 0.25, यू विल स्टिल हैव सम वैल्यूज हियर, क्योंकि यहाँ पर बहुत कम डेटा पॉइंट्स है, दैट्स व्हाई यू सी दिस मोर rigid form. Okay, but if you have many data points, you'll see a smooth curve, something like this. You'll see a more smooth curve जब ज्यादा डेटा पॉइंट्स होते हैं तब, क्योंकि यहाँ पर कम डेटा पॉइंट्स है, ओनली 10 डेटा पॉइंट्स है। यू सी दिस रिजिड कर्व, और इसके एरिया अंडर द कर्व निकालना भी बहुत इजी है। ऑल यू हैव टू डू इज जस्ट ड्रॉप अ लाइन फ्रॉम हियर टू हियर, ड्रॉप अ लाइन फ्रॉम हियर टू हियर। सो इफ आई विश टू जस्ट टेक दिस, रोल कर लेते हैं, इजी है बहुत। एरिया अंडर द कर्व निकालना भी. Just share my full screen so that you can see the mouse. Okay, so ये एरिया अंडर द कर्व कैसे निकालेंगे हम लोग? All we have to do is just draw some lines here, right? So यहाँ पर एक लाइन ड्रॉ कर दो, यहाँ पर एक लाइन ड्रॉ कर दो, यहाँ पर एक लाइन ड्रॉ कर दो, यहाँ पर एक लाइन ड्रॉ कर दो. ठीक है, ये क्या है? What is the shape? You can just maybe divide it into two. You have a triangle here, you have a rectangle here. Triangle plus rectangle. Then you have some rectangle here. Then you have another trapezoid here. You just do another rectangle here. You just add all of these sums and you get a area under the curve. In this case, area under the curve is 0.82. If you want, you can do it manually. You will get 0.82. Okay.
Okay.
Pretty straightforward, right? There's nothing confusing, and you should never get confused with the ROC. What exactly is ROC and what exactly is AUC associated with the ROC? Now, higher the AUC, the better the model. In this case, the AUC is 0.82. If there's another model which will give you different predictions, right? So the predictions that you get here in this particular example are one type of predictions from one model. So this predictions that you get are scores from one model. So maybe these are the scores from model number one. Model number two might give you some different score. It will tell that this is not 0.3%, but this is 0.25%. This is not 5, this is 0.55. This is not 0.5, this is 0.65. Maybe this is 0.51. Maybe this is still 0.1. Something else. Okay. Something else. Something else. Okay. 0.5. Okay. So this is your model 2. So model 1 के predictions आएंगे, model 2 के अलग predictions आएंगे. And then both of them are going to give you a different ROC curve. Okay. So maybe one of them is this ROC curve and one of them is this ROC curve. We can get that value too. So ये भी R square से आपके, इसको मैं comment कर देता हूँ. ये नए R square का ROC curve कितना आता है? इसका कितना है? 0.82 है. तो ये नए का देखते हैं कितना आ रहा है. That is not defined. Okay. Need to comment all of this here. Okay. तो इसकी वैल्यू आई 0.76. इसका एरिया अंडर द कर्व. तो कौन सा मॉडल अच्छा है इन दोनों में से? मॉडल 2 और मॉडल 1 में से कौन सा अच्छा रहेगा? इसका आरओसी कितना आया? एयूसी कितना आया? 0.82. इसका एयूसी कितना आया? 0.72. राइट. तो कौन सा मॉडल अच्छा रहेगा, 1 या 2?
First one.
The first model is better than the model number 2. Okay. Now the question is, आप जब मॉडल डिप्लॉय करते हो, ठीक है, when you deploy the model, what should the threshold be? ये परसेंटेजेस तक तो ठीक है, लेकिन आपको जब आउटपुट देना है यूजर को, तब तो आपको बताना पड़ेगा ना कि whether it is a 0 or 1, whether the person has a heart disease or whether the person does not have a heart disease. जब कोई पेशेंट आता है, you cannot tell that there is a 50% chance that you have a heart disease or there is a 75% chance that you have a heart disease. You have to tell a definitive answer. You have to tell, okay, you have a heart disease. Then you have to tell someone that you don't have a heart disease. You cannot tell percentages, because percentages are not easy to wrap the head around, especially for the end user. Maybe you can understand that because you have background in stats and background in maths and all of that. But someone who is a layman does not understand all of this. So you have to tell what exactly is the threshold. Okay. Now, what exactly is the threshold depends on this value here. Okay. If you're okay, if you're okay to make more false positive errors, okay, if you're okay to make more false positive errors, then choose a threshold which is smaller. Again, if you're okay to make more false positive errors, then choose a threshold which is smaller. Lower the threshold, more false positive errors you are going to make. Okay. But if you want your model to be really stringent, that no, I don't want to make any false positive mistakes, then choose a threshold which is higher. Make sense?
Yes.
Okay,
Yes.
and all of that depends on the use case. So अगर आपको use case में पता चलता है कि it's okay to make some of the false positive mistakes, in that case you will say okay, my threshold is 0.25, 0.4, 0.3, whatever you decide on. Okay, I would decide 0.25 here. If I want a balance between them, then 0.5 is something that will give me the balance. Correct? At least in this particular case. But अगर model pick up करना है तो model I'll pick up model number 1 only, because model number 1 is giving me a better AUC. एक बार model pick up करना है, उसके बाद में threshold decide करना है कि कितना रखना है. Okay? First, select the model which is a good model. After that, you can decide on the threshold. That threshold is what? It's just a uh, line in the sand. Okay, you can move that anywhere you want based on what are the requirements. Okay, अभी अगर आप टेक्स्ट बुक में पढ़ोगे तो टेक्स्ट बुक में एक और चीज है. When you make a mistake, you can assign a dollar value or you can assign a score to it. Have you read that part?
Not yet.
Okay, so वो reading part complete करो and then we'll discuss that in the next session. I'll ask you all. ठीक है, what is that?
Okay.
Yeah. Hmm. So now let's get back here. So ROC curve really is nothing but a way to decide which model is better, and after that you have to decide on the threshold which will tell you whether your model is conservative or your model is stringent. Conservative model is someone who is sorry, liberal model or the model which is okay to make false positive errors are someone who are on the right side, and the most restrict or strict models are someone who does not like false positive rates. Okay, for example, if you make a false positive, then it's an expensive thing. Okay, uh, example of making a false positive would be which is where it is expensive is let me just think where it is not okay to make a false positive. uh, Okay, let's take this example where the doctor has to decide where whether the surgery should be done or not. Okay, and this is the final model. If the model says the surgery is okay to be done, then he'll cut the patient and do the surgery. In that case, if the model gives you wrong predictions, the patient is already cut now. Okay, it should not give you a wrong prediction. It should not give you false positive. Maybe it should ask the doctor to do some more tests, but if it gives a false positive, that means there's going to be an operation and the patient is going to be operated. Correct. So that could be one of the examples which is high stakes, and it's also not okay to make false positive mistakes there. Okay. लेकिन अगर कोई टेस्ट होगी जहां पर सिर्फ आपको रिपोर्ट मिलता है, in that case you can make false positive because you can have multiple tests done after that. But if there is one test which is maybe the penultimate test, and after that you really have to decide something, then it's not okay to make false positive mistakes. The example that I shared was the operation example. Okay, let me just do one thing. Let me share this with you all. So try to just do this particular part again. Okay, आप offline जाके बाद में check करना है, ठीक है? Let me just send you all here and ask for answer. Yeah, good to see some people are solving the functions and religiously doing the Python practice. इंटरव्यूज में पाइथन में ही अटकते हैं बहुत सारे लोग. ठीक है, अगर आप पाइथन की प्रैक्टिस नहीं करोगे तो आपके इंटरव्यूज क्रैक नहीं होंगे. फिर आप डेटा साइंटिस्ट के इंटरव्यू के लिए बैठोगे, डेटा एनालिस्ट के लिए इंटरव्यू के लिए बैठोगे, डेटा इंजीनियर, जो भी इंटरव्यू के लिए बैठोगे उसमें पाइथन पूछने ही वाले हैं आपको. सो पाइथन से कोई भी एस्केप नहीं है. यू कैन नॉट एस्केप पाइथन. It's going to be a reality for as long as you are going to be in the field. Okay, since you have already selected that you want to be in the data science, data analysis field, you have to learn Python. It will be painful. Okay, it has been painful for many people, but you have to pass that particular threshold. एक बार आप वो threshold पार कर दोगे, after that it will become easy for you. Okay, so for that you have to go through the painful process of making the habit to write code in Python. Okay, so please, you have to practice Python. Okay, I cannot uh, tell how important it is to practice Python. If you don't practice, at the end of the course, you'll be like, you didn't learn anything. That's what you're going to feel when you sit in the interviews. Okay, now let's go back here. I think already discussed what AUC is. Alright, now let's just talk about the advantages and disadvantages of AUC. So when you have class imbalance, जैसे कि fraud example, ठीक है? There are going to be millions of transactions which are not fraud transactions, and there will be handful of transactions which are fraud transactions. So this is an example of an imbalanced data set. एक particular class है which is not fraud, which is heavily present in your examples, and there is one particular class which is the fraud class. It is not, it is very rare. Similarly, the heart diseases. Okay, there will be millions of people who are going to get tested, but not everyone is going to have the heart disease. Correct. So if you have imbalance like that, it's good to use ROC AUC to select the model. Okay, and because these models are not dependent on the threshold, AUC curve is basically just moving the threshold up and down and getting the value. Correct. So it can tell you overall how the model is performing, if the model 1 is performing good or the model 2 is performing good. Now, there are some disadvantages too. I think first one is little bit difficult to explain even in the interviews. So what it says is it is insensitive to the class probabilities, which means जो class की probabilities आपको मिल रही है, for example 0.5 के ऊपर आप बोल रहे हो कि it is a positive, और 0.5 के नीचे या फिर 0.5 की वैल्यू जब होती है तब आप बोलते हो 0, right? 0.51 पे क्या हो रहा है? You are making it 1, right? So there is not really a high
Yes.
differentiation between 0 0.5 and 0.51. So there is, it is not sensitive to those minute details. Okay, that is what this particular disadvantage means. It is insensitive to those minute details. So 0.50 के ऊपर आपने directly बोल दिया कि उसको 1 बोल दो, और 0.50 के नीचे आपने directly बोल दिया 0 बोल दिया, तो 0.51 पे प्रॉब्लम हो जाता है, because it is so close to that 0.50 threshold that you really are not able to quantify that information properly in the model or in the results. Okay. Second is it does not consider something called as costs. Okay, what is the cost of false positive? What is the cost of false negative? That information cannot be encoded in the ROCEOC. So when you go back and read the textbook, वहां पे आपको cost के बारे में information लिखी रहेगी. ठीक है? एक बार वो cost वाली information पढ़ लो, and then we'll discuss that in the next session. Okay, so you can write this down and we'll move forward. All right. Let me know once you're done and we'll proceed.
Done, sir.
Done. Good. ठीक है। सो आपको आरओसी और एओसी कब यूज करना है? सबसे पहले तो जब बाइनरी क्लासिफिकेशन होता है तब आपको आरओसी यूज करना है। जब मल्टी क्लास होता है तब यू डोंट हैव टू यूज आरओसी। ओके, सो जस्ट गेट दैट डाउन। जब मल्टीपल क्लासेस होते हैं तब मे बी यू हैव टू बिल्ड मल्टीपल आरओसी एंड एओसी कर्व्स। ठीक है, एंड देन यू कैन टेक एवरेज ऑफ ऑल दोस आरओसी एओसीज टू select what is the best model, but usually it is used in the binary classification. Okay, और जब आपका डेटा बैलेंस्ड होता है तभी भी आप आरओसी एओसी यूज कर सकते हैं। So I think that's it for today, guys. Make sure आप वो जो कैगल का नोटबुक है वो ओपन करके प्रैक्टिस करो। एंड व्हेन यू गेट अ चांस, कैन आई गेट लिंक्स ऑफ योर कैगल्स? जितने भी लोगों ने कैगल का अकाउंट ओपन किया है, मैसेज करो। I think I have some of you already added to the list, but I may have missed a few people. Okay, just make sure you send me the Kaggle links.
Okay, sir. We will send it again.
Okay, yeah, thank you.
Okay.
And I would like you all to start thinking about your minor project now. So minor project में आपको एक या तो regression task या फिर classification task pick करना है. You can go out on kaggle.com and pick any data set that you like. But only concern or only thing that I would suggest is pick a simple data set. Okay? Don't pick very complex data set and then you'll have to change the data set because you cannot solve it. The goal of minor project is आपको जो data science के steps है वो ठीक से समझ में आए. Goal of minor project is not that you try to understand the data fully, you are completely dived into the data and trying to understand everything in the data. No. So pick a simple data set, something that is from your domain. Okay, if you have mechanical domain, then pick up maybe something about a cars data set, engines data set, something like that. Okay, if you're civils, then you can take some civil data set. But you should be able to pick up a data set and then do a regression or classification on that. कैसे करना है, क्या करना है, वो सब हम लोग पढ़ेंगे, लेकिन सबसे पहले आप डेटा सेट पिकअप कर लो. How do you pick the data set? You go on kaggle.com, you go on the data sets here, and you can search the data set here. Okay, so let's say I select cars data set. This basically gives me some used cars data set. Now there's a usability here which is 10. So usually it's good to have a data set which is having a usability of 10. It means it does not have missing data. It does not have big issues with the data. Okay. So try to pick some data set which is having a usability of 10 or closer to 10. and try to pick a data set which is smaller. So this is a really big data set. 275 megabytes is a big data set. This is 2 gigs, even bigger than that. Okay, try to pick something which is smaller. Maybe this 843 is fine. This 6 KB is also fine. Okay, 176 is also fine. So pick a small data set, but make sure the usability score is good. यहाँ पर data set में जाके search करना है. Kaggle data sets and search whatever data set that you like. और data set search करने के बाद में आपको open करना है वो data set और यहाँ पर code रहेगा उसका. So these are some things that people have worked on. Okay, code पे. You just have to click that and check how they have worked on things and just read a few. Just get familiarized with the process of data science. Okay, we'll formally learn how to do it, but it never hurts to start thinking ahead. Okay, करेंगे सब लोग?
Yes, sir.
Yes, sir.
Okay, all right. So I think that's it for today, and I'll see you all in the next session, which is on Friday.